Assalamu alaikum dear students. In previous lecture we discussed continuity of some special functions. Now today we are going to discuss continuity of a special function f of x equals to 1 upon x. That is, we will check the continuity of this function 1 upon x. Now which is same as to define the concept of infinity. That is, through the continuity of 1 upon x we will discuss the concept of infinity. Now in order to discuss the concept of infinity of this function 1 upon x, let x equals to a be any non-zero real number, then its limit is simply limit x tends to a 1 upon x is 1 upon a, and the value of this function at this non-zero real number a is simply f of a equals to 1 upon a. That is, the value of the function at a point equals to the value of the limit at given point. That is, limit x tends to a, f of x is simply f of a. So this means that this f is continuous at non-zero real number a. Now this is arbitrarily non-zero real number, so we can simply say that this f defined by 1 upon x is continuous at x equals to a, where that is at non-zero real numbers. Now we will find its limit at x equals to 0. That is, we will firstly discuss its continuity at x equals to 0. Now in order to discuss continuity at x equals to 0, we will firstly find its limit at x equals to 0. Now for this, right limit equals to, now a right limit means we are finding, or we are checking the behavior of the function close to 0 from right side. That is, in other words, we can simply say that we are finding the value of the function at the points which are close and closer to 0 from right side. Now the points closer to 0 from right side are 0.1, 0.2, 0.3, so on, or 0.01, 0.001, 0.0001, so on and so forth. Now at these points, that is at point x equals to 0.1, the value of the function is simply f of 0.1 is 1 upon 0.1, which is 10. Now f of 0.2 is 1 upon 0.2, that is 5. F of 0.3 is 1 upon 0.3, which is simply 3.33. Now if we consider the points which are much closer to 0, that is 0.01, now the value is 100. If we consider 0.001, the value is 1000. Similarly, if we consider 0.0001, the value is 10,000, so on and so forth. Now these points 0.01, 0.1, 0.2, 0.3, now they are in a increasing order. That is, 0.01 is less than 0.1, less than 0.2 is less than 0.3, so on. But the value of the function at these points is 10, 5, 3.33, 100 and 1000, which implies that the value is greater at the smaller points. Smaller is here 0.01, the value is here 100. So this means that f of 0.01 is greater than f of 0.1, greater than f of 0.2, greater than f of 0.3, which means that the value of the function is much greater than the for those points which are closer and closer to 0. This means that when we are approaching to 0 from the right side, that is x tends to 0 positive, because approaching means limit. Now the value increases more rapidly, that is f of x increases more rapidly, but we cannot find a fixed number which is next to 0, This means that if we consider the point which is much smaller, that is which is much closer to 0 from right side, then we can find infinitely many numbers between the number 0 and that number. So this means that f of x increases and increases more rapidly, so we can simply say that this f of x increases up to infinity, that is, its value increases much rapidly. So this means that when x tends to 0 positive, f of x approaches to plus infinity. That is, graphically we can say that when we are here, this is 0, it is 0, here 1, 2, now 0.1, 0.2 are here, Now when we are approaching to 0 from right side, that is we are approaching to 0 from this side or moving towards 0 from this side, the value of fx, that is simply fx, increases more rapidly. The value of fx is on this axis, which means that when we approach to 0, the value approaches to plus infinity. This is the graph when x tends to 0, x tends to plus 0, the f of x tends to plus infinity. Similarly, we can find the left limit. Left limit means to find or to check the value of the function at the points which are closer to 0 from left side. Now the point is closer to 0 from left side are 0.1, minus 0.1, minus 0.2, minus 0.3, minus 0.0, and so on. And the value of the function at these points is minus 10, minus 5, minus 3.33, minus 100. This means that if we consider the point is 0.01, it is greater than 0.01, it is greater than minus 0.02, it is greater than minus 0.3. So but the value of the function at these points is f of minus 0.01 less than f of minus 0.1 is less than f of minus 0.2, so on and so forth. So this means that when we are approaching to 0 from right and left side, that is here the graph is like this. When we are approaching to 0 from this side, which means x tends to 0 negative, the value of x, the value of f of x is negative and it becomes lesser and lesser. That is when we are approaching to 0 from left side, the value of fx becomes much less than the previous one. So this means that the smallest value is here, the smallest possible value is here minus infinity, because it is the smallest, or simply we can say that it is the limit or the lower bound of the negative numbers. So we can say that when x tends to 0 infinity, the value of the f of x approaches to minus infinity. That is this. When we are approaching to 0 from this side, the value of f of x approaches to minus infinity. So this means that right limit is here plus infinity, left limit is here minus infinity. So this means that limit does not exist for this function that is at point 0. So we can say that when a limit does not exist for a function at a point, we can say that this f is not continuous at this point. So we can join, combine these two statements as for this function, or the graph of this function is here when x increases, f of x decreases, when x decreases, f of x increases. That is, the graph is like this. This is the required graph for f of x equals to 1 upon x. Clearly at 0 there is a break in this graph, so it is discontinuous at, while as for non-zero real numbers it is continuous, because everywhere we have the connection between them, or there is no jump in the curve which represents f of x equals to 1 upon x. This means that when x tends to this x tends to 0, f of x approaches to plus minus infinity. It depends upon the situation. That is, x tends to infinity implies that f of x tends to 0. When x tends to minus infinity, f of x tends to minus 0. That is simply 0. So usually we can represent, or we write 1 upon 0 is infinity. 1 upon 0 is infinity. Now you know that infinity or minus infinity are not the real numbers. That is, real set is denoted by open interval minus infinity to infinity. This means that these minus infinity and plus infinity are excluded from, or and you know that from above 1 upon 0 we can simply say that it is infinity, rather infinity. It is simply not defined. Not defined means because 1 by 0 is not the member of this OR. But if we consider extended real system is that system which is actually the union of these two sets, OR and the set minus infinity and plus infinity. That is simply the closed interval minus infinity and infinity. Hence, in extended real system, 1 by 0 which is infinity, simply if we consider 1 by 0 to be infinity, then here it is defined number, defined. But 1 by 0 is, if we consider the function f of x equals to 1 upon x, it is here, it is still here discontinuous, because its limit does not exist in 1 upon in extended real system, because limit exists means left limit should be equals to the right limit, but here the left limit is minus infinity, the right limit is plus infinity. So we can simply say that the left limit not equals to right limit. In the extended real system also this limit does not exist. So inshallah in tomorrow's video lecture we will discuss the exercise, this first exercise, that is to check the discontinuity or the continuity of the function at the given point or over the domain. So thank you.